Hello, my name is Matthew Neely, and I work for Thermo Scientific. Today I'm going to talk to you about our latest and greatest LCMS solution, the Vanquish UHPLC and triple quad mass specs. So today's outline, as you can see on the slide presentation, we're going to talk about three topics. The first one being our new HPLC system, the Thermo Scientific Vanquish UHPLC system, which is the latest and greatest HPLC system that we have. The second topic we're going to talk about is our triple quad solutions. Whether it be an Endura or a Quantiva, we're going to talk about how these particular triple quads can bring your analysis into the state of the art. And finally, we're going to talk about the Thermo Scientific Chromatography data system, Chromeleon CDS, as it is used in quantitative analysis for triple quad analysis. So why a new UHPLC? Well, there's lots of reasons, as you can see on this list, and I'm not going to read them all to you. But the main reason is customers came to us and said, we want to do more with our HPLC and LCMS solutions. Whether it's more results, getting better data, higher performance or more performance out of the HPLC system, or just having more analysis done before the system fails and having a more reliable HPLC system. I like to think that our HPLC system is as reliable as your best friend. It's something that you can count on and be working in your laboratory day and night without you having to interact with it. But we didn't just look at it from the LC perspective. We looked at it from the mass spec perspective as well as the software perspective and tied it all together as a complete solution, the Thermo Scientific LCMS solution. So more results, better results, and a shorter runtime. So we heard you. We started off with a completely new portfolio. It's a new design from the ground up, and it's cornerstoned around the separation of the molecules by chromographic separation. The Vanquish UHPLC system touts a 1500 bar pressure specification up to 5 mils a minute to separate even the most demanding separations. It's built upon 30 years of engineering experience and knowledge and workplace to really have a very reliable and easy to use operation of your HPLC system. We developed new techniques and unique techniques with our 1.5 micron AccuCore columns so that we can have the greatest separation and with the minimal amount of runtime. We've improved our robustness and reliability and closed the gaps that pushed us beyond our previous limitations. This is a completely biocompatible HPLC, so it can work in almost any workflow, but it also has the capabilities of running any column that's out there on the marketplace. So, as you can tell, we've integrated very nicely with our LCMS solution. We've brought out a brand new column or a dedicated column for this particular technique. We have Chromeleon software to bring it all together and make it very easy to use for our customer base. And of course, the Vanquish UHPLC and the charger module can actually improve the amount of capacity that you have in your laboratory so you can get more results done in a given weekend. So we start off with power, right? As I mentioned, this pump can go up to 1500 bar or a little over 22,000 PSI. The flow rate can go up to 5 mils a minute. We can combine 2 channels of mobile phase in a binary gradient separation, but we can choose between 3 different mobile phases for each pump, which means I have a total of 6 solvents that can be on the system. 2 of them can be dedicated for application 1, 2 of them can be dedicated for application 2, and the third set can be a third application. So this increases the total utilization of your HPLC system. You don't have to change bottles in between use. Another thing that we were concerned about was accuracy, the accuracy of results. And if you actually overlay multiple injections of our HPLC system, you can't even tell the difference between the peak areas or the retention times. They overlay just perfectly and give you that confidence that when you make an injection, you know exactly what the results are going to be. We've improved our sensitivity by redesigning our variable wavelength detector and putting a light pipe technology in there so that we can increase the path length from 10 millimeters up to 60 millimeters, giving us anywhere between 6 and 9 times the sensitivity that we have in a traditional 10 millimeter flow cell. This also leads to confidence in results. The whole system, the lower pressure fluctuations, the specifications on the pump, the ATAC algorithm to basically compensate for thermal equilibrium, all brings us to very smooth baselines, good quantitation values, and more results in an easier fashion. So let's look a little closer at the particular modules. Here we're looking at the Vanquish binary pump. As I said, it's a 1500 bar pump up to 22,000 PSI. What does that give to you? That gives you a system that can work with almost any application that you're interested in. So it's very flexible. Whether you're going to run a 2.1 millimeter by 50 a 2.1 by 50 millimeter column today, you can easily switch out and run a 4.6 by 250 micron column tomorrow. It's very simple to change between application flow rate ranges by changing the column geometries. This is a new design in our pumping technology. It's a parallel pump. And this basically allows us to have a very small pressure ripple with minimal impact on the baseline. That increases our signal to noise ratios in our detectors and makes it a more reliable system, leading to longer column lifetimes. Less pressure ripple on the column means longer column lifetimes. All right. The other thing we've had is we brought out a new algorithm called ATEC, which is the Adaptive Thermal Effect Compensation. This allows us to really minimize or really have very accurate flow going through our HPLC system, which really gives us more accurate results in our retention time reproducibility as well as smoother baselines. And so this is the best flow and gradient reproducibility that we can achieve. One of the other fundamental things about this pump is we really designed it for ease of use. For instance, we have finger-tight check valves, which means you don't even have to pull a tool out of your drawer in order to take a check valve out and replace it. So it's very easy to operate on, very easy to maintain, and it really is ease of use or ease of interaction with your HPLC system. All right. If we look a little closer at our Vanquish split loop auto sampler, again, we had to engineer our own injection valve. There were no injection valves on the market that can handle the 1500 bar pressure specification. So what we did is we took a diamond-like carbon coating so that it has a really smooth interaction when the valve is switching between states, and that increases our overall lifetime of our injection valve. Our dosing meter or our syringe is put into the high pressure stream, so we can actually adjust the position of that particular syringe to adjust the gradient delay volume, and that's what it means by adjustable gradient delay volume. This gives us an easy method transfer or portability from other instrumentation and other instruments if you need to match the gradient delay volume perfectly. Another key avenue that we brought out with this particular auto sampler is automatic sample pre-compression. You can imagine if you have a sample loop that's 100 microliters of volume. When it switches from the load to the inject state, it instantaneously goes from atmospheric pressure up to 1200 bar or higher. The very first thing that happens is that sample loop has to compress, which drops the flow rate to your column, which increases the pressure ripple to your column, and all the things that you want to avoid during an injection routine. All right. This pre-compression allows us to have very close to the same pressure in the sample loop as the valve switches to inject, so that we maintain an accurate flow rate across the column, which gives us better retention time reproducibility for the early eluting peaks. That's, again, more confidence in your results. We have a new air-to-air cooling compensation. This is especially important for very humid environments like where I live in Houston, Texas. If you have the air-to-air cooling, all the condensation drops down into a catch reservoir, and we can pull it out with a little peri pump and keep your samples from swimming in the condensation. We can increase our sample capacity, which we'll see in just a second. We went from 3 well plates to 4 well plates in the standard auto sampler, but in the next slide we'll talk even about our rack loader that can increase that capacity even farther. The auto sampler is outfitted with automatic barcode reading, so it knows what kind of sample racks you're dealing with, and it can change that every time you open the door and you put a new rack in. It will automatically recognize what that plate is, so you don't have to go tell the software, I just changed from a standard well plate to a standard vial rack. So the Vanquish charger module is for those customers that have more samples that they want to do in a given weekend, right? So it's easy to do 1,000 injections in a standard auto sampler. But what if you wanted to go to 30,000 injections? You need more samples. So this particular unit is a robot that keeps all your samples organized. It has the same barcode scanning mechanism as in the auto sampler. It also has the ability to keep the same temperature that we have in the auto sampler, so that we know that our sample's integrity is going to stay pristine. All right. It can load up to 9 standard vial racks or 9 deep well plates, or you can put a shelf in there for 20 standard well plates. And believe me, 20 standard well plates is a lot of samples. but we can get through those in a given weekend. The Vanquish column compartment is a new device for us. It basically has two thermostatic modes, still air mode as well as a forced air design. So you can take advantage of adiabatic temperatures and UHPLC separations to make the most efficient peak efficiencies in your UHPLC separation, or you can use it in forced air mode for more conventional HPLC methods so that you have the ability to run conventional HPLC or UHPLC style applications on this particular system. It has a totally new active preheater that has a resistive heater that heats you up to your desired mobile phase temperature, as well as the samples up to the desired temperature before it hits the head of the column, so that everything is maintained at the right temperature. In addition, you can actually add on multiple column ovens, 1, 2, and 3, so that you can expand from 2 columns to 6 columns with a click of a button within the software. So the other nice thing about the column oven is that it can reside on either the right side or the left side of the HPLC system. So in the case if you have a Q Exactive, which is the picture on the bottom, the interface on that is on the right-hand side of the mass spec. So you can come right out of the column oven directly into the mass spec, minimizing the amount of tubing that's required for that particular configuration. However, if you have a TSQ Quantiva or a TSQ Endura, the interface is on the left side. So we keep the column oven on the right side of that stack so that it's directly between the HPLC and the mass spec as close as possible, so that we can, again, minimize the amount of volume that's required to go from the column over to the mass spec. Our Vanquish diode array detector, again, I mentioned it earlier, has a new light pipe technology. We have 10 millimeter and 60 millimeter path links, right? So it allows us to see more results in a given separation. We have 6 to 9 times as much sensitivity as our standard diode array, with the best signal to noise ratio and performance out on the market. Low noise and a very large linear range, up to 3000 milliAU. And we can simultaneously detect highly concentrated samples along with the impurities down at about the 0.01% level. So it works very nicely for FDA regulated style applications. So in general, the Vanquish system has better separations, better resolution, minimal peak dispersion because we tied it all together. This gives you a benefit of less matrix effects and more consistent quantitation, more consistent sensitivity. We can have faster analysis, right? So that we can get more results done in a given day. This can improve your productivity. We can do very confident results in retention time matching or retention time reproducibility, because they're all basically overlaid right on top of one another. That confidence gives you a much more confidence in what you're reporting is exactly the compound that you're interested in. And then of course our new enhanced core columns, our 1.5 micron columns, the AccuCore Vanquish, really is moving towards a more generic application so that we can do almost everything we want with the traditional C18 column. All right, so let's talk a little bit about triple quads, right? In the triple quads, a lot of people may have a large number of samples, or in some cases, they may just be very low concentration, right? So time is money, right? The faster you can get through those samples, the more results you can get, the more money you can make within your organization, right? Bottom line. So we always want to keep that in mind. And the TSQ Endura and the TSQ Quantiva bring this particular level of speed to the current marketplace. The TSQ Endura is an extreme quantitation value package. It's the best in class sensitivity and unprecedented usability and really good robustness. The TSQ Quantiva really is extreme performance and extreme quantitative performance. It can go down to antogram sensitivity, so it's a very sensitive triple quad mass spec, and its robustness is exceptional. All right? So here's some specifications, but the ones I really want to point out here are just simply the number of SRMs per second. Over 500 SRMs in a second. Nobody else on the marketplace can achieve this kind of number of selective reaction monitoring modes. All right? We have a new ion optic design in our Quantiva. This is what makes it more sensitive. It has the AIM technology, which is more or less a funnel or an ion optic funnel that brings in more ions into the mass spec so that we can increase the transfer rate into the overall detection mode. We have a neutral loss mechanism so that we can minimize the amount of neutrals that will eventually hit the quadrupole and our detectors. And all of these things together allow us to see signal to noise ratios, as you can see on the board, of over 100,000 to 1 for a traditional 1 picogram reserpine type concentration. So again, the Quantiva is really about sensitivity. The Endura is really about our entry level or quantitative value package for giving you the most bang for your buck. So here's an example. If you have a sample that has very low concentration, I might want to choose the Quantiva, right? Main reason, the ion optic funnel brings more ions into the MS, which increases my overall sensitivity. All right, so for demanding low sample concentration assays, we definitely want to go with the Quantiva, all right? For large number of samples, we can use the Vanquish with a charger, and we can add up to 23 well plates into my sample load, which is well over 3,000 samples in a given weekend, right? So tying together a Vanquish with a charger with the TSQ Quantiva can handle large number of samples in a robust fashion, even in a situation where you need the most sensitivity. For routine qualitation labs, maybe you're interested in, pesticides and food or things along those lines, you can look at a TSQ Endura. It's, really great as far as the LOD and LOQs are concerned, and it is really designed to be a robust mass spec in order to operate day in and day out, regardless of the abuse it gets. And we pull it all together because we know time is money with ease of use in our software. And that's what Charlie here is telling us. We don't have time to waste on determining how much of a particular compound is in, putting a report together and sending it out as part of a C of A. We want to basically go from samples to results as quickly as possible. And Charlie and Chromeleon basically bring that to us with an entire software workflow that you just tell it how many samples you want to go, and it basically goes out and runs those particular analysis. So, how do I include MS in your laboratory CDS? Currently, it's a workstation, and there's no way to work remotely, right? You have to basically be in front of your LCMS computer in order to operate it currently, right? Well, Charlie breaks down that door, right? He breaks down that barrier and allows you to even remote in from your home, if you want to, and run your LCMS solution, right? Now, of course, everybody wants to work from home, right? All right. So Chromeleon 7.2 support basically supports all of our HPLC systems as well as our TSQ Quantiva, TSQ Endura, and it is a great integration of our MS solution with our chromatography solution and the ease of use of being able to get from samples to results as quickly as possible. All right. You only need to install and validate one software package, so you don't have to learn other software packages that you may or may not find the features beneficial. All right. And we can use all the compliance tools of Chromeleon for our LCMS solution. So it gives you the ability to be 21 CFR Part 11 compliant. But mass spec customers want certain algorithms. They want certain features within their mass spec software. So we have integrated these things such as Genensis or ISIS. These integration algorithms that you're traditionally used with other softwares, you can bring them in and use them within Chromeleon as well. So let's take a look at what some of the data looks like. So here's a key component of Chromeleon. It simply shows you a sample list and the number of components that are basically present in this particular compound. If it's got a green next to it, it basically means it was identified, it was integrated and identified. If it's red, it basically means it was non-detected. If it's yellow, it's questionable. It might be there, you might need to look at it. So it's really easy to identify those color coding components to see what is present in your particular sample. I can click on any one of those things and it will directly jump right into that particular location. I can also use key Microsoft features such as a filter box or a star list of my favorite compounds or groups of compounds in order to quickly take a list of 600 pesticides and truncate it down into 10 or 12, which is much more manageable from a laboratory standpoint, right? So these components basically allow you to, you could tag them as your favorite components. You could tag them as, the peak ratio was not within a confirmation trace. That's what like I said, the red box was there. It says, hey, you might need to basically look at this particular compound. And it really makes it easy to see this without having to dig into the mass spec software and mass spec spectra and actually see and do the science yourself. As you can see, this is a very complex chromatogram, right? I mean, there's over 600 peaks in this particular view, right? I wouldn't want to have to go through and look at the integrations for every single one of those, right? Well, we did another thing, which is what's called MS quantitation channel. So this is the total ion chromatogram, or TIC, but we created what's called MS quantitation channel. If I have a table of all 600 of these components and I say, this is the mass to charge ratio that I'm interested in, then it will create a specific view for each one of those analyses quite simply. And now you can see the picture, and it's very easy to see these components that you're interested in. All right, these are your favorites list. These are the ones that your company is getting paid for, right? And you can quickly identify, yes, the peak was there. It's clean. I got a good integration. I can see my calibration curve, and I can get my table results right down below there. Really simple and easy to use. That's what Chromeleon gives you. I can click on the name of a component, and it drops me right into my mass spectra. It'll show me what the mass spectra looks like, right? I can either then do an extracted ion chromatogram. So this is showing here the main spectra at the apex plus the spectra on both sides so that you can see how pure that particular compound was as it was eluting through our chromographic separation. I can also then do some time spectra, and I can look at how this component changed from sample to sample within my sequence, which is what you're seeing here in the middle, right? This middle channel here. I can click on a particular name. I can see how did this particular thing change between the different analysis schemes, or I can use it to overlay the actual quantitation ion along with the confirmation ion so that I can see both of them simultaneously without having to dig through and create extracted ion chromatograms for both of those particular mass to charge ratios. But again, we can use SmartLink and component traces, as I just mentioned, that I can see a summary of all of the components, all the quantitation ions for every sample in the sequence, and just scroll through and see how they are affected on run by run to see if they are truly what we expect them to be. It's all hyperlinked together and easy to look at and easy to do quantitation. So you got thumbnails to decide which samples you're interested in or components that you're interested in, as well as the SmartLink icon at the upper right-hand corner there. Another nice thing you have here is you can either look at the views stacked or you can look at them in an overlaid fashion, right? So this really allows you to see the differences in an overlay versus a stacked view, right? Again, it's a single button click to change between these two graphical views. You don't have to go digging around in the software to figure out how to report those particular things. All right. Our final section here is talking a little bit about data processing, right? With multiple traces and possible hundreds of compounds and components, you've got hundreds of different calibration curves. How can you rapidly and accurately set up the component table, right? So there's existing data processing tools, and Chromeleon CDS are now complemented by a suite of MS-specific tools, such as integration with NIST libraries and SRM tables, so that we can bring those things in and easily identify and build our component tables, right? So all existing calibration modes and options to MS, we can easily extract ion chromatograms. We also have the additional MS-specific detection algorithms, such as Genesis and ISIS, and a full processing control on the component-by-component basis, right? So in this example, we're showing that you can simply click on the mass range to say, extract out that particular mass to charge ratio. But a much easier way to do this is actually just to click on a peak. So let's take a look at how you would do a manual extraction of a mass spectrum, all right? So here you have a chromatogram. You can click on a peak and it shows you the mass spectrum in the far right. Under the channels, I can right click and say extract MS channel. And it opens up a dialog box and it says, I want to look at a mass range. I set in a mass range as well as any smoothing or what channel, the name I want to give that particular extracted ion chromatogram. I click OK, and it extracts that particular mass to charge ratio, and I see an extracted, a graphical extraction of the XIC. The other way I can do that is simply click just below the axis here and basically change the range of which I want to put into my extracted ion chromatogram. And you can see the difference by having a single mass versus a window of masses in the representation of that on the extracted ion chromatogram. Very easy to do, to extend a range, decrease a range, or even just add a new channel into your overall running sequence. Once I like this view, I can add this channel to every chromatogram in the sequence by simply right-clicking and say extract from all samples. I can also use NIST library searches to look at the spectral libraries and see how they compare to other known mass spectra of these particular compounds. I can import compound databases from NIST libraries so that I can say these compounds are things that I'm interested in and this is what the mass to charge ratio should be. All right? All of this software, we can bring in these predefined compound lists and databases either from TraceFinder software, or we can use Excalibur raw files with component information and simply import that information directly into Chromeleon. When it comes to MS data reporting, it can be very time consuming. Multiple components and traces make generic reporting very tricky because not everything is named MS01. Some things are named with the mass to charge ratio. All right? How do you effectively report such large quantities of data? Well, Chromeleon gives you a whole new suite of tools for reporting your mass spec results, such as mass spectral plots, component trace plots, MS-related variables and tables. There's also new tools for reporting large amounts of multiple channels of data. You've got an auto-repeat function, so you can say, I like this table for this particular component. I want to auto-repeat it for every component in my list. And you don't have to do any more reporting. It simply creates that auto-repeat area and does it for every compound in the list. So very often, MS peaks often appear in certain detection channels or certain filters, such as in this case, TIC and the different full scan events, whether it be channel 1 through 10. All right? But what I want to do is be able to create a report that summarizes all of these things into one concise table. So in this example of PCBs, for instance, I can take the channel with the highest number of area counts or the highest area height and say, I want to selectively put that area in here, but I also want it to be displayed as what channel had the highest response so that I know where this data came from, right? So this is very easy to do, and it's very useful when you have thousands of samples or thousands of components that you're looking at. So here we're looking at antibiotics at the 1 ppb level, and you can see the various antibiotics, and you get good sensitivity and good reproducibility of this particular component. Here we're looking at a slide of 36 different antibiotics in a targeted screening approach. We're using our AccuCore Vanquish column, or a C18 column, which is a specific or dedicated column for the Vanquish. It's a 1.5 micron AccuCore material in a 2.1 by 100 millimeter format. You can see the mobile phase is just simply water with a little bit of formic acid and methanol, running at a more traditional approach of 400 microliters a minute and a gradient table of about 10 minutes. All right? All 36 antibiotics are represented here in this chromatogram using extracted ion chromatograms for those particular mass to charge ratios. Most of those antibiotics are separated out with a 5-minute detection window using our binary Vanquish system with a TSQ Vantage MS. Here is another example of 47 drugs of abuse, right? Using our same AccuCore Vanquish column, 1.5, 2.1, but in this case, instead of formic acid, we're using a little bit of ammonium formate in water, or ammonium acetate in water, with formic acid and methanol as the organic emulsifier. 500 microliters a minute, 50 degrees C, and about a 6-minute total cycle time for this particular assay. In this window, all 47 drugs of abuse were detected in a 4-minute window, which really means you can get well over essentially 15 samples done in an hour, which gives you a lot of throughput for a particular day. So in summary, Thermo Fisher Scientific has brought the total solution together whether it be the best LC on the market, the best mass spec in the market, all tied together with Chromeleon software for data visualization, data reporting, data processing, and the ease of use that makes our lives easier when in the laboratory so that we can get more done in our days with less effort.